Question 4. Some reactions of compound G are shown. Okay, this is compound G with aldehyde and alcohol group. After reaction 1 is formed dicarboxylic acid, so means both groups being oxidized. Sodium added to this G, we know that OH will react, okay, form hydrogen gas. Reaction 3 is Tollens reagent, so the aldehyde will react, and aldehyde itself will oxidize to carboxylic acid. Tollens reagent is mild oxidizing agent which can react with the aldehyde, and aldehyde will form this carboxylic acid. And after reaction 4, we see that H2SO4 heat under reflux. So COOH and OH, it can self-react, undergo this esterification, form cyclics. Okay, part A1, state the type of reactions occur in reaction 1. Okay, this one again, this is oxidation because the aldehyde and alcohol oxidize to the carboxylic acid. Part 2, suggest the reagent and condition required for reaction 1. It means the oxidation. We can use potassium dichromate 6, or you just put the formula, or KMnO4, acidified KMnO4. Both can be used. Okay, you must put acidified potassium dichromate or potassium manganate 7. And of course, this this oxidation, it must because we have to make sure it's all from carboxylic acid, it must heat under reflux. It's going to take some time. Okay, draw the structure of the organic product H from reaction 2. Okay, this one. So we know that the OH group will react with sodium, this one, and these hydrogens will substitute by the sodium, so it will form hydrogen gas and it will form salt. Okay, so the organic product means the salt, so you just put this O and A there, this part remains. Okay, again, for the reaction of alcohol with sodium, so it's always from sodium alkoxide with hydrogen gas. Part 4, state what you observe in reaction 3. Reaction 3 is this Tollens reagent. Because it says aldehyde group, you see silver mirror or black solid. Okay, give the type of reaction shown by reaction 4. Okay, just now the cyclics. Okay, reaction 4, this one, so it's esterification, right? Carboxylic acid and alcohol. Part B, G and J, they are structural isomer. And name the type of structural isomer shown by G and J. Very easy. This is first carbon, second carbon, third carbon, the fourth carbon. So OH now bonded to the last carbon. And the J here, this first carbon, second carbon, third carbon. Third carbon, it says OH. So the OH now located at different carbon. So that's why we call position, at different position. Okay, part 2, suggest one chemical test to distinguish G and J. It's quite hard to distinguish these two. Okay, it's quite hard to distinguish these G and J because they have the aldehyde and alcohol group. Okay, the only thing that we can do is we can use the iodoform test. Means we add aqueous alkaline iodine. So when we add aqueous alkaline iodine, the J will react. Why? Because this group is the one that can form methyl ketone. Means the iodine in alkaline is a mild oxidizing agent. It will help to remove this hydrogen and this hydrogen from the J, from this methyl ketone. Okay, that's why once the methyl ketone form, then it will form the yellow precipitate, CHI3, the iodoform. G will be no change. What we see, J will have yellow precipitate. Okay, now we have this reaction G with the sodium borohydride, okay, form this alcohol. J also use the same reducing agent, form this alcohol. And these two alcohol undergo the dehydration because alumina with heat, it will form the same compound K. So now part 3, state the role of sodium borohydride in the reaction. Very easy, is the reducing agent. So sodium borohydride is always reducing agent. Okay, so part 4, identify the organic product K. So it must be the same product. We try to draw the structure of these two alcohol. So these alcohol look like this. These alcohol look like this. When these two alcohol undergo dehydration, same catalyst and the heat that used. Okay, so we know that this alcohol will undergo elimination here and elimination here to form these two double bonds. In order for this second alcohol to form the same compound K, so this OH and this H need to remove, and this H and this OH need to remove together. So therefore it will form the same compound K. That's how the thing works. Okay, identify the organic product K. Very easy. So once you know is this, so you just put CH2, CH2, CH, CH, CH2, or you just draw the skeleton. Right. And if you want to name that, you can put buta-1,3-diene. Part C, P and Q have the similar molecular formula as G, so is C4H8O2, right? So in the previous part, right? So it's C4H8O2, and the P and Q structures given here. Now complete the table and give the expected observations for P and Q. Okay, so first one, bromine water added to P and Q, of course no change, both no change, no reaction because no CC double bond. Okay, 2,4-DNPH, if you react with carbonyl only, not carboxyl. This one is carboxyl, so it will not react. This is the ketone, is a carbonyl group, yes, it will form orange precipitate. Okay, if you put aqueous sodium carbonate, this carboxylic acid will react. This will not. So when it reacts, you see the gas form, so it's efflorescence. Okay, part D, the structure of compound L is shown. Okay, the R represent a hydrocarbon chain. Unknown, we have to find it out later. A student was asked to deduce the full structure of L. Okay, means including the R part here, right? And the IR spectrum for the L is given here. So from this IR spectrum, you should be able to get a few info. Okay, the X absorption at X will be the carbonyl. Y absorption Y will be CC double bond. Absorption Z will be CO bond. And you can find and get it from the tables. In exam tables will be provided nowadays. Okay, identify the bond responsible for the absorption X and Z. Very easy. I already told you, carbonyl. Z is CO bonding. Okay, absorption Y shows that L has a CC double bond present in R group. Okay, means this one, absorption Y. So this one, because it's around 1500 to 1680, so it's telling us inside the compound L it has this CC double bond. Okay, the student decided to treat the L, this one, with hot concentrated potassium manganate 7. The products are shown, this one and this one. Okay, so now from these two products you need to deduce what is R. Okay, first part 2, name M. This one is 6 carbon including the carboxyl carbon, so therefore it's hexanoic acid. Okay, use the info in D, deduce the molecular formula of L. Okay, this one you need to at least know how the structure look like. Okay, how we deduce a structure, you have to spend a little bit time to get it. Okay, so this one, this is R group, and the products formed, they are these two, and this R group again, it must have CC double bond. Okay, so since here form carboxylic acid, we know that here it must be 2 carbon, 1 2 carbon, means this R group, it must have 1 2 carbon, and then the CC double bond is here. Then these CC double bonds will break. Okay, this carbon will form COOH. Then it will be this product. Because now given M is the 6 carbon carboxylic acid, so means this part must be 6 carbon as well. So means this CC double bond break, so this part must have 6 carbon. So 1 2 3 4 5 6, and this carbon also, after it get oxidized, it will form COOH. So therefore it will form the hexanoic acid. Now, this is how to get the structure, because after the bond break, it will form this product and this product. So from these two products, we can deduce back the structure like this. Right. So if we know the structures like this, then we can deduce the molecular formula. So it will be C12H20O2, this one. Okay, that's all for this question. Thank you.